Hi, my name is Will Herman, and my teammates are Reagan Shield and Min Tron. And today we'll be presenting our Presentation 1 for Introduction to Simulation, or Engineering 460. And we are going to discuss the three types of simulation: discrete event, continuous, and Monte Carlo, as well as show examples of those types of simulation. And we will also discuss the history of Monte Carlo, as well as the main differences between Monte Carlo and the other two types that were mentioned. So first we'll talk about discrete event simulation. Discrete event simulation is a model that simulates the system by breaking the events into discrete sequences in time. All the events represent specific instances in time and represent changes in the state of the system. Between the events, it's generally presumed that the system does not change, so the simulation can easily transition from one event to another. And as we will see later in the video, this is different from continuous simulation, because for continuous simulation you are continuously monitoring the system. So for an example of discrete event simulation, we can take the Hey Cow restaurant at Liberty University. So our system entities would be the student waiting queue and the cashiers. The events would be our student arrival and departure, and then the states of the system would be the number of students in the waiting queue, as well as the status of the cashier. Is the cashier busy, or are they available to take another student? And our variables would be the student arrival time and then the cashier service time, and then we can simulate this in each of the events. For continuous simulation, it differs from discrete simulation in that progress and responses are always continuously traced using sets of equations, often differential equations. An interesting fact about continuous simulation is that one of the first ever computer simulations involving continuous simulation occurred in 1946. Also, continuous simulation can be used to predict various things, such as the trajectory of rockets, the dynamics of hydrogen bombs, as well as simulation of electric circuits. For an example of continuous simulation, we will be looking at the response of a pilot based on various hours of sleep. So for example, you could have a first run, assuming that you're using the same pilot, where he has gotten 8 hours of sleep, and then you could do a second run where he's gotten 7 hours of sleep, and a third run where he's gotten 6 hours of sleep, and then you can trace his vitals and responses the whole time throughout the simulation, and constantly monitor them in order to see the effects of various levels of sleep. So that would be an example of continuous simulation. Finally, we'll talk about Monte Carlo simulation, which uses repeated random sampling and computer algorithms in order to acquire analytical results. Often this is used when it is difficult or near impossible for other methods to solve certain problems. So it solves these deterministic problems using randomness. And the three areas where Monte Carlo simulation is mainly used is in optimization, numerical integration, and probability distribution. So an example of Monte Carlo simulation would be the traveling salesman problem. Now, Monte Carlo simulation doesn't have to be used for the traditional traveling salesman problem, because the goal is to minimize the distance traveled. However, if we were looking to minimize the time it takes between stops in order to minimize the time, then Monte Carlo simulation would be required, because travel time is so variable. You have traffic patterns, possible accidents, and other things that affect travel time. So randomness will be needed in order to solve this problem.
Alright, now I will go over a brief history of Monte Carlo. Monte Carlo methods are a broad class of computational algorithms that rely on repeated random sampling to obtain numerical results. They use randomness to solve problems that might be deterministic in principle, and are often used when traditional approaches are difficult or even impossible to use. Before Monte Carlo, simulations tested previously understood deterministic problems, and then statistical sampling was used to estimate uncertainties within the simulations. Monte Carlo simulations invert this approach, allowing for the solving of deterministic problems using a probabilistic analog. One of the early variants of Monte Carlo was used by Buffin's needle experiment, in which pi was estimated by dropping needles on a floor made of parallel and equidistant strips. The modern version of the Markov chain Monte Carlo method was invented in the 1940s by Stanislaw Ulam while working on nuclear weapons projects at Los Alamos National Laboratory. His work contributed to the eventual development of the hydrogen bomb and became popular within the fields of physics, physical chemistry, and operations research. Now I'll go over some brief differences between Monte Carlo continuous and discrete simulation. So as we stated before, Monte Carlo allows the user to model the probability of different outcomes in a process that cannot easily be predicted to the intervention of random variables. Discrete simulation is an application of Monte Carlo simulation where the simulation of systems are mainly driven by events which occur stochastically in points in time. A few examples of these systems could be queuing and inventory systems in industry, like the hay cow example Will gave previously. Also, discrete simulation models the system as a discrete sequence of events rather than continuous. Now, continuous simulation is appropriate for systems with a continuous state that changes continuously over time. For example, a system could be an amount of liquid in a tank and or its temperature. You could describe the system with a series of differential equations. Continuous simulation allows you to solve these equations numerically. Here are references for this presentation, and thank you for listening.